Ciao! You're about to watch the recording of my speech at Droidcon Lisbon 2024. This is the second time I speak about Google Maps and Jetpack Compose at a conference. It's really similar to the first one that I already uploaded, now on the screen, about Google Maps and Jetpack Compose, which I performed at Droidcon Berlin 2024. If you've already watched that video, you won't find many differences, but there are still some differences because by the time that I did the second speech at Droidcon Lisbon 2024, it was start of September 2024 and a few months went by after Droidcon Berlin 2024. I'm Luca, an Android engineer working on native mobile apps since Android KitKat. If you're new to the channel, welcome. If you already subscribed, welcome back. The speech was recorded live at Droidcon Lisbon 2024. I will leave links to more specific video on my channels about the topics that I'm covering during the speech. If you want to see the official recording of the Droidcon Lisbon, I will leave the link to the video down in the description below, so please feel free to reach there and look at the video. If you plan to attend Droidcon Italy 2024, stay tuned until the end of the video because I have a surprise for you.
Hello, thanks for joining me today in this talk about Google Maps and drawing on it with Jetpack Compose. I'm Luca, I'm an Android engineer, that's my Twitter handle and my YouTube channel. I made a series of Google Maps and Jetpack Compose on my channel if you want to check it out later, and the Twitter handle is because I will publish these slides after the talk. So Google Maps and Jetpack Compose. By drawing, I don't necessarily mean those things, although it's possible, and we'll see later on how to do those as well. How many of you uses Google Map in their application, roughly? Okay. How many with Jetpack Compose? Oh, almost everyone. Okay, perfect. I never use Google Maps without Jetpack Compose, so this talk won't be a comparison between the two technologies. The Google Map Compose library has been divided into three libraries. The main one contains the Google Map with controls and configuration of the map itself, all the main drawing things, so markers and marker windows, circles, polygons and polylines, and the overlays. One of the other two is the clustering inside the Compose util library. And then we have another one, which is the Compose widgets that contains the scale bar and the disappearing scale bar. I won't be covering this last one in this talk, since it just adds the scale bar on top of the Google Map to display how big the zoom level is, basically. Okay, so this is the Google Map composable function declaration. It's a big one. The main part is the last parameter, the content, which can be used as a lambda, and it's a Google Map composable annotated composable function. Before going inside the Google Map composable function, though, I want to show you how we can customize the map itself before drawing on it. And that's done with the properties, which is an object, map properties, and the UI settings, another object, map UI setting. The map properties allows us to customize the map a bit with enabling the building drawing, the indoor or outdoor only, displaying the traffic data. It lets us define a bounds for the camera, so the user can't move the map outside of the boundaries. And the most important one would be the map style option that allow us to customize how the map is rendered on the screen. There is a styling wizard, the link now on screen, that give us 6 presets to customize how the map looks like. And from those 6, we can start customizing it. We have a lot of options: administrative, landscape, points of interest, road, transit, and body water. And for every single one of them, we can customize the fill and stroke color and the text as well. Once you're done with the wizard, you can export a JSON file and import into your project, into the raw folder, and load it using the map style option, load raw resource style, providing the context and the file itself. That's the deprecated way, though. Google Maps suggests to use the styling wizard online, create a new map ID in the map cloud console, assign this style to the map ID, and then specify in Android Google Map composable which ID your map is using by using the Google Map option .mapid builder here. The map UI settings allow us to add a few things on top of the map. The first one being the compass enable. It shows the compass on the top left corner of the map. The compass is shown only if the map is rotated. If north is not pointing up, then the compass is shown, and a tap on it will make the map straight again. We have the map toolbar that is shown on the bottom right corner of the map and is shown only when a point of interest is currently selected on the map. The My Location button enable is on the top right corner and locates the user on the map. This requires permission, so don't enable this button if your app doesn't have the permission from the user. You might get a crash. And last one is the zoom control that places the plus and minus at the bottom right corner of the map. Another thing that has been added later than when I started writing this talk is the Google Map color scheme. Before this option, if you wanted to change the coloring of the map based on the system setting, light or dark theme, you had to listen to that change and load a different style yourself. Now you can hard-code it by using the light or dark, or make it follow the system with one of those three options. Now, let's go inside the Google Map composable function, and the first thing I want to talk to you about is our markers and clusters. Those are the classic markers that we all know about on Google Map. We can use the standard icon, as we just seen. We can customize the hue of that icon. We can use a completely custom icon, and we can create custom info windows that are shown when the marker is selected on the screen by a tap. This is the composable function of the marker. There is no required parameter. You can literally just write marker inside of Google Map, and it will place a marker with no position, so you won't be able to see the marker. To specify a position, there is the state parameter, which is a marker state. And as you can see, it is using a remember marker state. And this is now required since the version 6.0 in order to prevent recomposing the map every time the position of a marker has changed. We can change the hue of the default icon by using the bitmap descriptor factory default marker and providing a hue. And the library gave us 10 different values to change the color. But I don't think any of us want to actually use one of those colors. The icon is not a drawable, so you can provide a resource ID directly. You need a bitmap descriptor. But it's not that hard to load the drawable, create a canvas from that drawable, draw the bitmap on the canvas, and returns it. And with this way, I suggest you to use the remember, so it won't be recomposed whenever it wants. And another thing here is the offset that you need to pay attention to, because if you're using an icon, you might need to tweak the offset a bit in order for the point of the custom icon to be precisely where the position should be. And this will be the result using a completely custom icon for the marker. If you want to have a marker info window on the marker itself, and customize it, you need the marker info window. There is a default implementation that is shown by using the marker alone itself, but you will need to provide a title and a description, which is the snippet string, nullable in this case. The marker info windows allow you to also specify a content, again, as the last parameter, and customize all the clicks on the info windows on the marker, long click, or closing the window. And inside that content, you can use whatever composable you want. Here, I'm just using a column, which shows the title with a different font style, description, if there is any, and if the data that is being used for the marker has an image, also the image. And this is the difference. On the left, the default marker info window implementation when there is title and description, and on the right, the code that I just showed you. If you have too many markers, they might overlap, and it's not nice to see 20 markers overlapping one another. And cluster is what you might want to use. Cluster allows us to group marker by distance. You can completely customize the tab handlers on the marker alone and on the cluster. And you have full control-ish of the graphics. To use cluster, you need declustering. You need a cluster item, which is an interface that requires you to specify a position that is a latitude and longitude object. And then you have 3 more parameters, which are all nullable: title, description, and z-index. The z-index is used to determine which marker is drawn on top of the other if they overlap and are not clustered together. It shouldn't happen, though. This is just a really simple implementation: location, name, and description, and hard-coded z-index 1 to all the cluster item. You can specify null to let the default implementation go and do its job. This is the clustering function, one of the 2 implementations that we can use. And the only required parameter is items, which is a collection of the interface that we just showed, cluster item. We can customize the click, item click, the info window, click and long click, and then 2 composable function, UI composable function, cluster content, and cluster item content. This is the default implementation. If you just provide a list of cluster item to the clustering function with nothing else provided, it uses the default marker and a circle with the number of markers that are clustered in that position. And this is quick random implementation of both of them customized. You might want to use the marker inside the customization of the cluster item content, adding, I don't know, maybe a column of a name or something, and then the marker. Unfortunately, you can't. If you try to do so, you get an illegal state exception. This is because the cluster content and cluster item content are marked as UI composable, while the marker composable function is using the annotation Google Map composable. So if you want to use the marker, you need to get an icon and place an icon, which is just a composable inside of your customization. The other clustering function that we can use is this one. It also accepts the item, which is, again, a collection of cluster item, and then a cluster manager that we will see can help us add a few things. To get a cluster manager, we have the remember cluster manager function that returns a nullable cluster manager. We can specify the cluster content and cluster item content, again, as composable, and a render. To get a render, that's that. Oh, no. Okay. To get a render, we also have the remember cluster render function that also has cluster content, cluster item content, and cluster manager. to get the, again, remember cluster manager to get a nullable cluster manager, so null save check to get the manager. We can then create a cluster render by providing the manager as the parameter. I like to use the cluster content and cluster item content inside the render. Just makes more sense to me to specify them in a renderer and not in the manager. And then we can provide the manager to the clustering composable function. This won't work though, because the render, although we provide the manager in the remember cluster render function, it's not linked to the render. To do so, we will need to set the renderer properties on the manager with the render that we just created. And we need to do so inside a side effect. Otherwise, there is a race condition on a nullable value, and the entire app crashes. So with this done, then we can use custom render for content, item content, specifying a manager. But we did nothing more than we were already able to do with the other function of clustering. So the one thing that we can do with the manager is changing the algorithm that is being used to group the markers together into a cluster. We have two ready-to-use implementation of the algorithm. One is non-hierarchical view-based algorithm, and the other one is non-hierarchical distance-based algorithm. The former takes into consideration the screen width and height, and cluster together the markers only if they are inside the view. So all the markers outside of the current section of the map that is shown to the user are not taken into consideration and are not rendered at all. But we can specify in the first one how close two markers need to be in order for them to be clustered together. The second one instead allows us to set a max distance between cluster item, which is in pixel, if I'm not wrong, and as soon as two markers are closer than that distance, they will be clustered together. This will take into consideration all the markers in the clustering, even those outside of the view. So it's a bit more computational here. And then once we have an algorithm, we can set the algorithm to the manager. And with that way, we can tweak how the manager works. For the value, I've seen that 150 is roughly a good value for a city as big as London and between 20 and 50 markers, but it will depend on how close they are. You might want to play around with it a bit. Now, let's talk about shapes. We have circle, polygons, polylines. And circle, this is the composable function of the circle. It requires us to specify only one parameter, which is the center, which is a latitude and longitude parameter. If you specify only that, you will see nothing on the screen. This is because it defaults to a transparent color and a radius of 0. I opened an issue on the Google Map composable library. If you want to go to the link and upvote it, it's been there since March 5th. To change this default behavior to require a radius and change the color to black, as it's the one default being used on the other shapes, such as polygon and polylines. If you tweak the circle, specifying the radius and the color, this is what is being drawn on the map. It covers the map entirely. This is because, as you can see here, the circle composable function doesn't have a transparency parameter that we can change. But we can change the fill color, its radius, the stroke color, the stroke width, and the stroke pattern. The stroke pattern can be a list of anything between dash, gap, and dots. And you can order them as you want to create a different line. And Again, if you want to change the transparency of a circle, you need to change the color that you provide to either the fill color or the stroke color, applying an alpha to it. If you don't want a border, you can either specify the stroke color to be transparent or the stroke width to be 0. And both of them will remove the border from the circle. And as you can see, this is a half transparent blue circle on the map. Polygons and polylines are really similar. There are just a few differences. Again, just one parameter is required, which is the points. That is a list of latitude and longitude objects. And if you just define a list of points and provide it to the polygon, you will see a polygon on the map. You don't need to specify a duplicate point because the polygon composable function will close the polygon for us. So you can use a set of points and it will be closed. Here again, we can change the fill color and the stroke width. And we can change the stroke pattern as well here, as we did for the circle. Small changes. And again, there is no transparency. So if you want to the polygon to be half transparent, you need to set it on the color. Another parameter that the polygon has is holes, which is a list of latitude and longitude points. You can provide either only one list to have a hole inside of your polygon. The stroke is applied both inside and outside of the polygon. Or if you want multiple holes in your polygon, you can specify as many lists as you want, and the result will be multiple holes inside of your polygon. If one or more points of a hole is outside of your polygon, it will subtract the part inside of your polygon and add the part outside of your polygon. This is basically, I don't know if anyone have ever used Figma. When you subtract two components that are only partially overlapping, the subtraction will happen only on the part inside. And last thing about the polygons is that the order of the points matters. As you can see, by just changing the orders with the same points, you get quite different shapes drawn on the map. Polylines are basically the same as far as parameter list. Again, the points is the only one required, and the default implementation is a black line. We can tweak the color, the start cap and end cap, which we'll see in a moment, and then the pattern again. The pattern is applied on the entire polyline. And the start and end cap are those things, so the very last point of where the first and the last point in the list. The polyline also accepts a span parameter, which is a list of style span where you can define colors. Each color of this list is applied to one segment of your polyline. So the first color is applied between the first and the second point, the second color between the second and the third, and so on. If you specify less color than segments, what happens is that it goes in order. It colors the first one, it colors the second one, and then keeps the last color on the rest of the line that you have specified. If you have the correct number, it colors all of them. If you specify more, the one exceeding are basically ignored. We can also use gradients on the polyline inside the span. If you specify only one gradient this time, it's applied to the entire polyline, but you can specify as many gradient as segments you have, and they will be applied on each segment. With this polyline, you could go back to the second slides and create the beautiful figures on the map. And now overlays. The overlays, there are two overlays, ground overlays and tile overlay. Each of them comes with some complication. The ground overlay, it's basically just an image that is placed on top of Google Map, and you have to specify the image itself and the position of the image, which is not a latitude and longitude position alone, but it's a ground overlay position. A ground overlay position can be created from a latitude and longitude bounds, or from a single position and the width and the height. Basically creates a rectangle on the map. If you use the create by providing the latitude and longitude bounds, you need to specify the southwest and northeast point in order to create the rectangle. One key point is the anchor, which is where the pixel 00 of the image that you provide is drawn inside of this rectangle, usually 0. You can specify the transparency on the ground overlay, so if you don't want to completely cover the map but have something half transparent, you can do so. And the image, it's basically using the same function that I show you for the custom marker icon at the beginning. The only difference here is that I'm scaling the canvas to match the size of the actual image on a map. The hardest thing with ground overlay is getting the correct point where the image needs to be drawn. Usually you have this data already. If you're just trying it yourself, it might be a little bit hard to get the point correctly. But yeah, as soon as you have an image, you can overlay it on the map itself. The other overlay is the tile overlay, and it requires us a tile provider. And the tile provider is an interface that gives us a constant, which is no tile, and a function that we need to override that receives 3 parameters as input and requires a tile. A tile is a rectangle representation of the map, and every tile has the same size at a given of the others at a given zoom level. The map is not, when you use a tile provider, the map is not loaded entirely, and the tiling system is what the actual Google Map application uses to render the map. So we receive 3 parameters. Those 3 parameters are X, Y, and the zoom level. The map is divided into square, and we can have possible different details level for each zoom level. And it uses the Web Mercator projection, which is how to project the sphere on a 2D plane. And it's been a standard since forever. That's what Google Maps and all the other API uses. The tile at 0, it's always at the northwest corner of the map. At zoom level 0, we have 1 square. At zoom level 1, the map is divided into 2x2 grids of tiles, so 4 totals. And the number of tiles is 2 elevated at the zoom level by 2 elevated at the zoom level. We have 2 examples that we can take a look at for the tile overlay. One is the coordinate tile provider, which basically writes the coordinates and the zoom level on the map. This can be found, I guess, in the composable map library as an example. It basically creates a canvas and writes on the canvas the X and Y position with the zoom level, and also draws the square containing the data. Yeah, basically it creates a stream, compresses this stream, and returns a tile with the bitmap data. And to draw the coordinates, it uses a canvas, writes using the text paint on the canvas. And this is as a result. You might see that the coordinates are not really latitude, longitude, because yeah, it represents the X and Y on the grid of tiles that the map is divided into. There's another one, which is way easier to use. It's a URL tile provider. the URL type provider give us a function which is getTileURL. We receive the X, Y, and zoom, and we need to return a URL. This offload the entire computational thing of creating a bitmap to show the bitmap on the map to a server. You just need to provide a URL. There are services that give us images based on the URL that we query. This URL is to be used here, and then the image that the service returns is rendered on the screen. For example, I mentioned that you can have different details level at different zoom. This is the same tile overlay at 2 different zoom levels. The one on the left is zoom 0, just draws the UK, and that's zoom 12 with many more details. Inside the Google Maps, you're not restricted to use just one of them. You can use multiple, a selection of them, or even all of them together. And that will be the end result if you use tile overlay, ground overlay, markers, but there is no clustering here, but you can use clustering as well here. And that was it for me. If anyone has any question, I think we still have plenty of time.
Welcome back. I hope you enjoy the recording. As promised, if you're planning to attend Droidcon Italy 2024, I have a surprise. As a speaker there, I have access to 50% discount, which I can give to anyone. So if you're interested in one of those 2 discounts, please leave a comment down below and I will be sure to reach out to you. This will be a giveaway, so if I will have more than 2 interested in those discount codes, I will select randomly 2 of them. That was all for this week's video. Thanks for watching, and till the next time, peace.